Hi, Professor TA and the class of 5810 section 001. Today I'm recording this session for the reading assignment 2, and I took the topic knowledge discovery of geochemical patterns from a data-driven perspective. And let's begin this. Coming to the summary, we have often heard of big data, but did we really heard about big Earth data? Yes, big Earth data often refers to the Earth science studies data collected from a myriad of sources, satellite observations, ground sensor networks, etc. The big Earth data is difficult to analyze due to the complexity of its nature. uh, the real complexity is the data is not homogeneous, multi-source, multi-scale, high-dimensional, or non-consistent. Scientists have researched a lot to gather this data in the past few years. This data is not only useful for mineral extraction and environmental study, but also plays a vital role in global geochemical mapping and the establishment of one global geochemical network. Here, geochemical mapping is basically to understand the changes that the chemical elements undergo when they are lying on or below the Earth's surface. We would need to explore more indirect models to evaluate these geochemical patterns using a data-driven perspective. For example, frequency-based models, machine learning, etc. These models do not suffice to understand the geochemical patterns, as there are also lies anomaly in these patterns that would need some advanced machine learning algorithms to recognize and understand the geochemical anomaly. With the big Earth data accumulated needs to be analyzed, and for that we have a new procedure called geodata science GDS procedure. The GDS is a combination of geoscience and data science. The GDS procedure can be divided into three tasks basically, like statistics, data mining, and data insights prediction. Yes, data insights prediction. And This is the whole summary of the knowledge discovery of geochemical patterns from a data driven perspective. After going through the summary, I've done the critical analysis, which have been I have done the critical analysis. Coming to the research, the scientists started their research and gathered a total of 2090 samples and analyzed them for 15 mineral elements. Among those 15 mineral elements, the 7 geochemical samples mentioned below were computed using plasma mass spectrometry, copper, zinc, cadmium, lead, tungsten, molybdenum, and gold. The 2 geochemical samples mentioned below were computed using emission spectrometry. They are silver and tin. And the 2 geochemical samples mentioned below were computed using plasma atomic emission spectrometry, that is barium and manganese. And the fourth geochemical sample mentioned below were computed using fluorescence spectroscopy, like arsenic, bismuth, mercury, and antimony. All these 15 mineral elements were gathered among the 2090 samples. And coming to the data driven methods used to understand the geochemical patterns, first one is LISA. LISA stands for local indicators of spatial association. The LISA method helped to measure the spatial association in the subregions of the actual research region. As the spatial data increases and expands, more tools would be required to understand its distribution. One of the tool is exploratory spatial data analysis. ESDA used to identify the spatial properties of datasets using the two autocorrelation coefficients, like Moron's I coefficient and Garris C coefficient. With the help of these coefficients, we can identify the local clusters and outliners within a dataset. The coefficient I value can vary from positive and negative. In case it is positive, it indicates the future of a cluster, whereas it is negative, then it indicates the future of feature of the outliner. Like here, we have a major drawback. The drawback is nothing but these coefficients can analyze the global statistical data, but cannot determine the local inconsistency of every observation of the given data. So this is one of the major drawbacks for one of the data-driven methods used to understand geochemical patterns, which we call simply LISA. And coming to the second data-driven method, it's like it is PCA, and the full form is principal component analysis. Like coming to the principal component analysis, like it is the oldest and the most reliable tool, as it is used to reduce the dimensionality in big data sets to improve interpretability with minimum loss of information. Like the PCA is an algorithm that would convert the correlated features into a linear set of uncorrelated features using the mathematical orthogonal transformation. Like there also exists a closure problem in geochemical data, as all the elements contained in every sample sum up to fixed value of 1. Like this closure problem distributes the correlation between the existing geochemical variables and makes the interpretations more difficult when other correlations are found using the same variables. So the closure problem exists in the componential data sets. Like coming to the PCA, again the principal component analysis, like there is another drawback. The method PCA is most suitable to analyze the compositional data in an open system rather than in a closed system. So this is the drawback for PCA. And coming to like the third data driven methods, like it is deep auto encoder network, and we call it as DAN, and DAN is mostly used for geochemical anomaly detection for the exploration of minerals. The auto encoder networks are the ones that are trained in such a way to extract the data from the noise and reconstruct the data back to its original form. To train the DAN, it must undergo three stages again: the pre-training, unrolling, and fine-tuning. Like these are the three stages. And the main objective of the DAN is to match the output with the original input, which minimized reconstruction errors. Like, and we have another drawback in this DAN is like it is mostly used for small sample sizes, as the reconstruction errors would be low and produce a high error of big sample sizes. And after going through all the data methodologies used by geochemical patterns, like after gathering, like these are the results. Like spatial geochemical patterns exploration, like like if we can see here, the major ores that were analyzed using spatial correlation were gold, antimony, lead, and zinc. Like among 2090 samples points collected earlier, and the final analysis is tabulated below. Like here we can see the first row consists of all the metals, like all gold, antimony, lead, and zinc. And here HH cluster, which is nothing but H high cluster or outliner, or HL cluster stands for like outliner in which high values are surrounded by low values. And here LH cluster is nothing but outliner in which low values are surrounded by high values. Like here there is another like neither outliner nor cluster, and this is the result. Like for gold it is 6, and neither outliner nor cluster is 60, 76. And coming to antimony, it is 110. Like the high cluster or outliner is 4, and like the outliner in which low values are surrounded is 57, and neither outliner is 1502, and so on. Like you can easily get when you look into the table results. And there exists a spatial correlation between gold and antimony, or similarly there exists a correlation between lead and zinc. Geochemical elements association selection, like the ores gold, antimony, lead, and zinc, and copper were categorized into three forms of data. Like they are raw data, log transform data, and ILR transform data. The above three data were plotted using box plots, and one observation can be made for the mineral exploration that all the plots are right skewed and symmetric. Coming to the conclusion, the mineral gold and antimony, lead and zinc is correlated, and spatially the closure problem in mineral exploration can be resolved using ILR distribution of data. The anomaly in the geochemical findings from Dan and the actual location of the mineral also were spatially correlated. This is the conclusion, and questions I wanted to ask are like, do the samples which were taken by the scientists sufficient to get the required output? And the second question is that can the same data driven perspective techniques be used for more sample data, or will it be different approach? These are the questions which I wanted to ask. And thank you, Professor, for giving me this opportunity to record the video. And